Well, good afternoon, good morning, or good evening, depending upon where you are in the world, and welcome to today's DevOps.com webinar. I'm Charlene O'Hanlon, moderator for today's event, and I welcome you. As always, we have a great webinar on tap today, but before we get started, we do have a few housekeeping items we need to go over. First of all, today's event is being recorded, so if you miss any or all of the event, you will be able to access it on demand. The webinar will be living on the DevOps.com website that you can go there under the webinars / on-demand section and find it there later on, hopefully later on this afternoon. And we are taking questions from the audience. So if at any time during today's presentation you have a question for our speaker, please don't wait, don't hesitate, just use your GoToWebinar control panel and submit your question. And we'll take a few minutes near the end of today's presentation and go through those questions. And finally, at the end of today's webinar, we will be doing a drawing for 3 $50 Amazon gift cards. So stick around, hopefully you'll be one of our big 3 winners. Okay, with that, we'll kick off today's webinar, which is Anatomy of a Build Server Attack. Our speaker today is Chris Ford, who is VP of Product at ThreatStack. Hi, Chris. Welcome.
Hi, Charlene. Thank you.
I'm going to turn it over to you and let you do your thing now.
Super. Let's jump right in. Hi, everyone. Thanks for joining our webinar today. I am Chris Ford. I run the product team here at ThreatStack. And today we're here to talk about modern build pipelines and how you should be thinking about security when it comes to those build pipelines. We'll touch briefly on what is considered more traditional build time security mechanisms, and also things you should be thinking about with respect to the underlying infrastructure that underpins your build infrastructure. And we'll look at all this through the prism of a very common attack that we're seeing, which is attacks directly on the build server. So let's go ahead and get started. My voice is a little scratchy today. It is April in Boston, after all, but we will soldier on. So this is my obligatory infinity loop diagram that you have to present when talking about DevOps. And we won't dwell here, but the reason we all practice DevOps and modern build pipelines is all about velocity. It's about enabling rapid delivery of new features to production and increasing the pace of innovation, which of course translates into business value, competitive advantage. And I like to put this infinity loop here because this is really oriented around developing and shipping code into production in a continuous loop, from building and testing code to releasing and deploying it, and then monitoring and measuring that code as it runs in production. And our viewpoint here at ThreatStack is that security can also be viewed as a continuous loop, and that some of the things you do when you're operating and observing your code running in production can also apply to security and should in fact apply much earlier in the build lifecycle. So think about security as a continuous loop as well. Now, if you're, of course, building a modern CI/CD pipeline, you're doing it in the cloud, and DevOps, as shown on this slide, come together to create this pipeline. So the middle of the slide shows what is a sort of a traditional schematic of a build pipeline. You've got developers that are writing code independently, and that code is being integrated or checked into the source control system like Git or Subversion, and building automatically where it is then pushed into staging environment for test and ultimately being pushed into production. Now, from our perspective at ThreatStack, we often see these applications being delivered as microservices that are in containers. And again, the same benefits apply. You get to push features into production more quickly and increase the pace of innovation. But if there's one takeaway from this slide that I want to leave you with, it's that CI/CD components run on top of infrastructure. And this is largely on-demand, auto-scaling infrastructure. It's infrastructure as code. And that virtualized compute and storage gives you the ability to rapidly create that infrastructure, and it gives you the same sorts of benefits around business agility and cost-effective consumption. However, bear in mind that your CI/CD pipeline runs on that infrastructure, And that can pose some risk from a security perspective. And this is the area that we're going to drill into in subsequent slides. So let's talk briefly about current state. Generally, when people talk about build time security, it's oriented around a series of checks or gates as code travels through that pipeline. These are code scanning that help to ensure that the code that's moving through the pipeline is free of vulnerabilities or malicious code. I put some examples here on the slide. This is not a complete list, of course, but we often see customers implementing vulnerability scanning of container images or container image assurance. There's a couple example vendors who do quite a good job of this. Tenable and Qualys come to mind. But these are now standard tools for doing that sort of vulnerability scanning for code that's moving through the pipeline. These tools are necessary and good, but perhaps in some ways they are insufficient to meet the needs of more modern threats that we're observing. The real challenge here is that those build time security tools are focused on the code as it moves through the pipeline. What they're not focused on is the tooling, the processes, and the infrastructure that make up that pipeline itself. And increasingly, exploitation of the CI/CD pipeline can compromise the integrity of what's moving through it. If you don't know, ThreatStack has a co-managed service. And so we work with customers to help them monitor their infrastructure for both identifying proactively areas of risk and also for identifying threats that are ongoing. And we are observing increasing attacks on CI/CD infrastructure, in particular, the build server itself. We'll get to that in just a moment. So at the end of the day, build systems have runtime components that should be on your radar in terms of things to monitor and keep secure. If we break down this build pipeline into its individual components, each of them runs in its own cloud environment generally. You've got your source control system running in the cloud. You've got a separate environment for your build server and your build infrastructure. Staging and production oftentimes have their own environments that you need to worry about. And each of these environments is API and internet accessible, including your source control system in many cases. Now, these are placed in a way that they're easily accessible. Of course, you want developers to have easy access to your source control system. And obviously, if running in public cloud, your build, staging, and production environments are API and often internet facing. But each of these environments has multiple layers of cloud infrastructure that can turn out to be attack vectors. And we're going to talk about the concept of integrity stacking in a few slides. And essentially the idea there is that each layer in your cloud infrastructure is an attack vector, and each layer depends on the one that's underneath it. So exposure to any of those layers in the cloud stack can be a huge risk. Another common configuration issue that we see, because you're dealing with multiple environments here that comprise the build pipeline, is that they can have different ownership. For example, IT can own your source control system. You have an ops team that's looking out for your production system and an engineering team that's looking after build components. And because they have different owners, there can often be inconsistent controls in place across these environments, and that's something really to watch out for, because a weak link in this chain, so to speak, can allow attackers to gain access to other systems where your controls might be a little bit more strict. And finally, best practices around build pipelines have a great deal to do with automation. You want to do things for sure like automated build and deployment. And automation often can widen the blast radius for security issues. So if components are compromised in your build pipeline, like some malware that could be distributed as part of a container image. For example, automation can then spread that malware across your infrastructure without your knowledge. So automation, while it is a real boon from an ops perspective, it can be a risk that you need to watch out for when it comes to security. I'll leave you with this thought on this slide. Your infrastructure that underpins your build pipeline, your CI/CD process, has runtimes that you should be looking after. So we mentioned at the top of the presentation that, well, after all, this webinar is all about the anatomy of a build server breach. And this is something that we're seeing quite often now. Attackers are, in fact, targeting the build server. It turns out that the build server, like Jenkins, well, it runs on Linux largely. It has a runtime component to it. And the very nature of the build server makes it a pretty unique access point, and it has functionality that make this very interesting to attackers. So it's a common target. And there are many ways to get access to a build server. Some of the mechanisms that we see are around exploitive vulnerabilities. These are host level vulnerabilities that give an attacker access to the build server, or even leveraging a stolen infrastructure key, perhaps acquired from GitHub or something similar. So your build server is indeed exposed and is very interesting to attackers for these reasons. Number one, as we pointed out, they are oftentimes publicly accessible. And if you're like many, you may not have the same controls in place in your build environment that you do in a production environment. So they're, in fact, sometimes easier to access for a would-be attacker. Number two, the build server itself can act as a bridge to other environments. For example, an attacker could get access to a build server and then attempt to establish persistence there and then begin looking for ways, whether it's monitoring network traffic or looking for keys that would allow her to move laterally to other environments like staging and production. We see a lot of this sort of attack where someone will look to gain persistence and then find their way to systems, even if it's to build their own system, that in fact does have access to production data, like sensitive data that might be stored in a database somewhere. So the build server can definitely act as an access point and a bridge to other more interesting environments for attackers. Bullet 3, the build server also connects directly to source code, so that if you have an attacker that is less interested in persistence and lateral movement, they could at minimum do a smash and grab where they're gathering artifacts that may have been either archived or left behind. This could be code signing keys or other important artifacts that are intellectual property like source code. So the build server is definitely an attack vector. And I think the most nefarious attack that we've seen is when a build server is turned into an effective means of distributing malware throughout the organization and throughout your environments, because it has both access to staging and production environments, but also because it connects through to corporate infrastructure. So from the build server, you could begin then to move left in the diagram on this slide and begin to place malware on corporate endpoints like developer laptops. Before we talk about a specific attack that we've observed, I wanted to revisit this idea of integrity stacking. Now, we mentioned that these components like your Jenkins server or your build server in your CI/CD pipeline, they do run on infrastructure that has a runtime component to it. And we'd like to talk about this notion of integrity stacking, where as you move up this stack from virtualization and hardware up through host instances like EC2 if you're running in AWS, and then containers that run on top of that, and even in the application tier, The business value certainly goes up as you go up the stack, but also so does the surface area. There is more attack surface to be concerned with. And each of those layers in your stack inherently trusts the one that sits below it. So your app and your containers trust that the host has not been compromised. And so everything beneath it is just a black box. This is important to think about when we start to look at a specific attack on the build server and how compromise of the machine image that it allows you to start up an EC2 instance or a virtual server instance can end up compromising the layers that reside above it. So let's look at a common build server attack that we have seen. As we mentioned a few slides ago, attackers can get access to your build system. It's publicly available, either API accessible or facing the internet. And what we see is either exploiting of vulnerabilities that are on the host or theft of infrastructure keys can give an attacker access to the host on which your build system resides. And we have observed this in which the attacker then is able to inject the AMI, and this is in the case of AWS, of course, but this is the machine image that is used to spin up virtual servers. And if you are able to inject that or infect it, let's say install a kernel module in that machine image, and that machine image is not running at current, this gives you a really nice way to inject some malware and then distribute that malware when machine images are started up, and those go undetected because that injected AMI is trusted. And then, of course, as you might expect, everything above that virtual machine in the stack can also be compromised. So that's what we mean when we say that the build server can be effective means of distributing malware. One thing to keep in mind as well, when you think about this layered approach to your cloud stack, is that the shared responsibility model means you will, in fact, be responsible for various elements of that cloud stack that underpins your CI/CD pipeline. In a very simple example, if you're running virtual servers, then you're responsible for everything above the virtualization layer. If you're looking at the use of managed container services like ECS with or without Fargate, then for certain you'll be responsible for securing everything that is above the host level in the stack. Even if you're looking at serverless and platform PaaS services like AWS Lambda, still there are artifacts that can be compromised. So up and down the stack, you have elements where build server access can in fact compromise your system, whether it's the machine image, the Docker file that specifies configuration for containers, or even release artifacts up at the app tier. And if you think about that integrity stacking, everything at the top of the stack relies on everything beneath it. There's some additional complexity here as well that you should consider around your infrastructure, and that's that there are various control planes or orchestration layers that you should be mindful of observing as well. Things like AWS APIs or Terraform that control the spinning up of machine images, or container orchestration like Kubernetes that dictates when containers or pods start and stop. Watching these control planes can also be an indicator when something is not right. For example, rogue containers or rogue pods could be an indicator that an attacker is attempting to spread that malware that we talked about in that build server attack. So you want to have visibility to each layer of the cloud stack. In addition, you want visibility to the control planes that interact with them. And much of this is your responsibility. So how do we view this problem at Threat Stack? I'll introduce this notion of security observability in a moment. But if we go back to our infinity loop diagram that represents DevOps, each of the stages in that build pipeline has infrastructure that underpins it, from production to build environments, test environments, and even deployment. And so you really want to be observing behaviors in each of those environments that could be indicative of a threat or an attack, like that build server attack that we showed you. And so instead of thinking about monitoring and observability as simply an element of production environment security, you really need to stretch that to the left and start thinking about observability for all your environments across your build pipeline. And I use the term stretch left intentionally here. There's a lot of talk about shifting left. And I think sometimes that implies to people that by shifting left and doing some things like code scanning, like vulnerability scanning in containers, that obviates the need for monitoring observability. It certainly does not. So you don't want to change from monitoring infrastructure to moving toward build time security scanning. We think that it's a combination of both that is necessary to ensure security best practices. So you're stretching left, you're moving or supplementing your build time security that you have in place today with observability so you can identify threats across your build pipeline. So since we've brought up the topic of security observability, I thought I'd jump in and talk about some of the key principles of security observability and what we mean by it. Observability is a term that is more and more being used in a DevOps context, but it also applies to security. And when we're talking about security observability, number one, it requires that you're gathering signal from across your infrastructure, regardless of environment. So observability really tells you a lot about the working of a system by observing telemetry from that system. And you can't get a good picture of your build pipeline unless you're looking at all of the various components of it, from your source control system to your build server and infrastructure through your staging and production environments. So it needs to be full stack. So you need to be looking at host, container orchestration, and even visibility into the application layer is important. And finally, add to that the visibility to your cloud console. This is the API level activity that indicates that someone is either making configuration changes or starting up machine images or containers in a rogue way. So security observability is full stack and cross environment, but it's also proactive. We're not just looking for individual indicators of an attack. We're gathering telemetry from all these environments so we can be proactive about identifying future areas of risk. This is really about identifying areas of security hygiene that you need to look after. We like to say here, good operations is good security. And by getting visibility to all the telemetry coming from your infrastructure, you can be more proactive about identifying hotspots that you want to fix down the road. Security observability, third bullet, is also highly contextual. So you're not just looking for indicators of threat, you're looking for deep context that helps you reduce the mean time to know when an incident occurs. So not only do you want to see behaviors that might be indicative of a threat, you want to know what led up to that incident. You want to be able to paint the whole picture of what was exposed, how an attacker may have gotten access. You want the context to be able to very quickly identify the problem. And so that means gathering deep, rich telemetry from throughout your infrastructure. And finally, if you really want to extend observability to all the elements of your build pipeline, it's our contention that this sort of observability has to be built in. You've got to be integrated with cloud native infrastructure early in the SDLC to ensure that you have coverage by default. So if you have machine instances or images, you want to make sure that you've got the presence of an agent to be able to gather telemetry from it. You need presence in containers as they spin up so that you're identifying risk there. So the more security observability is built in, the more flexibly and easily you can stretch left, and extend security observability to your entire build pipeline. Now, here are some of the key risk indicators that you're going to watch out for. This is not a complete list for sure, but all of these things are examples of behaviors that you should be keeping an eye on at various layers of your cloud stack in those runtime environments that underpin your build pipeline. In the case of your control plane, you want to be looking for things like suspicious logins, suspicious instance creation, or even changes to cloud service configuration. As you move up the stack to the host and the virtual machine that runs there, you want to look for lateral movement. You remember we talked about the build server being a pivot point from your build environment into staging and production. So you definitely want to look for lateral movement, attempts to hide activity using time stomping, and modification to things like and access to secrets files through file integrity monitoring, file opens, deletions, even access to files. These are all indicators of an active attack or someone who's looking to establish persistence and move around your infrastructure. Also keep an eye on CVEs here. You want to make sure you understand what software is vulnerable at the host level so that you can prevent access to that host. The same, of course, applies as you move up the stack to containers. You want to be looking at things like container logins, the same sorts of intrusion detection capabilities that we saw at the host level. And container orchestration, as Kubernetes and other orchestrators become more and more popular, we see this as a large surface area for attack now, largely because these tools are still relatively new, they're complex, and so they can be ripe for configuration error. So definitely be watching container orchestration as well to ensure they're properly secured to avoid some sort of threat or risk. Even at the application tier, just to close out the slide, you want to be thinking about providing feedback to developers using a micro agent, things like improper use of crypto modules, unsafe configurations and package dependencies, and in the case of AppSec, even being able to detect active attacks like SQL injection, NoSQL injection, and cross-site scripting. So think full stack when you're thinking about security observability. So conclusions that we draw from looking at modern CI/CD pipelines and build infrastructure is that the traditional build time security approaches like code scanning, these are absolutely necessary and should be part of your security regime, but they're insufficient. Really, your build infrastructure is something to look after because it can and will be used as attack surface to both grab sensitive information and also gain persistence and move throughout your infrastructure. So you should be monitoring that infrastructure to ensure that you're observing behaviors that are indicative of a breach of that build infrastructure, and you're servicing areas of risk so you can be more proactive about implementing the right controls across your various environments. And finally, when you're thinking about monitoring, think in terms of full stack security observability that allows you to cover the various layers of that runtime stack that underpins your build infrastructure, including a host, container orchestration like Kubernetes, and even applications. And finally, ensure that you're observing the control planes that interact with these various layers. As you might expect, ThreatStack has a solution for security observability. We have, by default, presence in these various areas of your infrastructure through both an agent-list API integration and also an agent-based presence that can either be deployed as a container or deployed on the host. These agents and API integration give you visibility to monitor each layer of that cloud stack, including the control plane. All of that telemetry is fed up to the ThreatStack platform. We do operate as a SaaS, so it's very easy to get started. That telemetry is used both for incident response, so you can identify those behaviors that are of interest and immediately troubleshoot and address the incident. But they're also, that telemetry can also be used in your own data lake. So you can look at the raw telemetry from across your infrastructure and draw some conclusions about your security posture. Look for trends in terms of security hygiene and identify proactively areas of risk that you may want to focus on next. So that's the prepared material that we had for today. I hope you found it informational. Charlene, I guess we'll take some time for questions now. Did you want to close out with some thoughts before I take questions?
Yes. Just want to remind the audience that if you do have a question, just go ahead and use your GoToWebinar control panel. Near the end of today's webinar, we are going to be doing the drawing for the 3 Amazon gift cards. So I'll be doing that right before we close things out, whenever we are done with the question and answer period. So with that, I'll just turn it back over to you, Chris, and you can go ahead and dive right on into the questions.
Yeah, sounds great. The first question that we got in was around support for Azure, and the answer to that is yes. When you think about multi-cloud environments, security can become even more complicated, and it's we maintain that it's important to have visibility to workloads, whether they run in AWS, Azure, or other third-party cloud providers. So when you have a presence at that Linux host, when you have security built in by default to Linux workloads, by the way, Windows is coming soon for ThreatStack customers. Yes, it's important that you're feeding telemetry up from those workloads to a central place where you can look across multiple cloud environments. We also got a question around detection of Spectre or Meltdown vulns inside the build infrastructure. Yeah, we've had a lot of questions around Spectre and Meltdown, and ThreatStack can absolutely identify when a host has been compromised using those vulnerabilities, because we're observing the behaviors that once an attacker gets access to a system through a vulnerability, we can see when they're starting to do things like escalate privileges, move laterally. So we do have a very comprehensive view of that underpinning build infrastructure. Let's see, we got, I think, one more question. And that is, what are the security benefits and concerns of a managed container service? Good question. And it's one that we get a lot. When you think about that shared responsibility model, if you remember, with a managed container service like ECS or EKS or even Fargate, there are a couple different flavors of those services to keep in mind. I'm thinking ECS and EKS particularly. Those can be run with or without Fargate. And if you're running your own Kubernetes infrastructure, you definitely want to be plugged into and monitoring both whether Kubernetes is configured properly and also some more of those runtime behaviors for Kubernetes, like starting and stopping of pods. If you are leveraging something like Fargate, that is a much more of a managed container service, you still do want presence in and around those containers to be able to identify if they're secure and behaving properly. And in here, I would definitely recommend also integration with the AWS control plane, so you can identify through something like CloudTrail when containers are being spun up improperly or not. It does, managed container services make operations much more simple, but they tend to obscure the layers that sit below it. A lot of customers don't feel comfortable with that. But definitely, even in a managed container service, there are layers of that infrastructure that you're still responsible for. I think we've got time for one or two more questions here. Let me take a look at the list. One question is, does a threat stack agent analyze raw network packets on hosts? The answer to that is no. We're really looking for behaviors. We can see network connections in and out of those hosts and containers, which can be very instructive in terms of things like lateral movement or data exfiltration, but we're not actually looking at raw network packets. We leave that to network-based intrusion detection systems. And one more, can you clarify what is meant by build servers being publicly accessible? Sure, and this is not necessarily true in all cases, but if you're running your build server in public cloud infrastructure, of course, those public cloud providers make their API accessible so that you can spin up new infrastructure, spin up new environments, and make changes there. It's definitely something to watch for as you leverage public cloud, that they are not necessarily open to the public, so to speak, but those APIs are accessible for anyone and are often internet facing. Well, that's all the questions that we have today. Look, my contact information is on this slide. If you'd like to continue the conversation and go into some of your questions in more detail, please feel free to reach out. My email address is posted here. Thank you very much, everybody, for joining today. I really appreciate your time.
Great, great. Thank you, Chris. Real quick, want to remind the audience that today's event has been recorded. So if you missed any or all of it, or if you just want to listen to it again, just go to the devops.com website, click on the webinars tab, and it should be waiting there for you under the on-demand section. Give us an hour or two to make sure that it can get live, and then we'll get it up on the website. Also, before we sign off, I do want to do the drawing for the 3 Amazon gift cards. So without further ado, let me go ahead and do that. Okay, our 3 $50 Amazon gift card winners are, first one is Brian Maloney. Congratulations, Brian. Our second winner is, let's see, Stephen Franson. Congratulations, Stephen. And our final winner for today's webinar is Risa Nishimoto. Congratulations, Risa. Thank you for being a part of today's webinar. Christopher, thank you for giving such a great presentation. Appreciate your time. And I want to thank the audience also for joining us today. This is Charlene O'Hanlon, and I'm signing off. Have a great day, everybody.